Sri Gurubhyo Namaha. Welcome to our online project Ekalaiva. Last class we have discussed about the versatile nature of carbon, and now we are going in detail about the compounds produced by carbon, that means carbon compounds. Okay. So, if the compounds are made up of carbon, they will be bonded, that means the compounds will be bonded with carbon and hydrogen. So, specifically most of the carbon compounds are called as organic compounds. Why are they called as organic compounds? Because they are present in nature, okay, and then the sources of the hydrocarbons are from the organs of plants and animals, so that they are generally called as hydrocarbons. Now, let us learn in detail about the hydrocarbons and how they formed, what are the bonding nature and what are the uses, all that things we are going to discuss now. Carbon compounds, which are generally known as hydrocarbons. Okay. So, hydrocarbons are made up of the compounds which are made up of hydrogen and carbon. As it is the compound made up of hydrogen and carbon, it is called hydrocarbons. Okay. So, these hydrocarbons are actually called as organic compounds because carbon attached with hydrogen to form these hydrocarbons. You know, this compound is a well-known compound which is called as methane, which is a hydrocarbon. Why is it called as hydrocarbon? Because it is a compound which is made up of carbon atoms and hydrogen atoms, so that it is called as hydrocarbons, right? Next, how to represent the hydrocarbon bonding nature of the hydrocarbons, that means how the electrons of carbon and hydrogen are shared among themselves. Let us check that. We have an example here, methane. In this methane, there is one carbon atom and 4 hydrogen atoms. Okay. So, electron dot structure, already I have introduced about the Lewis dot structure. It is nothing but the valence shell electrons will be represented by some symbol. We can use any symbol. Either it may be cross symbol or a dot, whatever it is we can use. Okay. So, when we draw the electron dot structure, it shows that the compound contains one carbon atom, and you know that the valency of carbon is 4, which means carbon has 4 electrons in its valence shell. Okay. And each electron of carbon is going to share with hydrogen atom. So, it requires 4 hydrogen atoms to make a compound of methane. Okay. You know that hydrogen is uni-electronic species, which means that hydrogen contains only 1 electron. Okay. But carbon totally it contains 6 electrons. Why are we representing only the valence electrons? Because they are only involved in bonding. So, only we are taking the bonding electrons of carbon. Okay. So, likewise all the 4 hydrogen atoms have their electrons. Okay. So, now the electrons of hydrogen and carbon are going to share mutually to form a compound of methane. Now, this electron of carbon is shared by hydrogen. Likewise, the 4 electrons of carbon is shared by 4 hydrogen atoms. Okay. So, now if you take carbon, this carbon is going to share the electrons of its valence shell with electrons of hydrogen. So, this is how we can represent the molecule of methane with the help of electron dot structure to understand the bonding nature in carbon and hydrogen very easily. Okay. So, here this pair of electron is forming a single covalent bond, and this pair of electron will form one more single covalent bond, and here single covalent bond. So, the pairs of electron are taking place in bonding, so that it forms a compound called methane. If you check the next member, it is ethane. The formula shows that C2H6, which means that it contains, the compound contains 2 carbon atoms and 6 hydrogen atoms. Okay. So, how these compound will be represented using the Lewis dot structure? Let us see that. Now, it shows that C2H6, you know that valency of carbon is 4. So, 1 electron of carbon, 1 electron of the second carbon will be bonded, shared among themselves. So, that forms single covalent bond. And the other 3 electrons of carbon will be mutually shared with hydrogen electrons. Okay, like this. And then the second carbon of this compound also contains 4 electrons, and then the electrons, among the 4 electrons, 3 electrons are shared with hydrogen, 1 electron with carbon. Now, first let us represent the sharing of electrons of carbon and hydrogen, so that we will be getting 3 single covalent bonds between carbon and hydrogen. Likewise, here in the second carbon also, there are 3 single covalent bonds between carbon and hydrogen. Now, this first carbon will share the electron of carbon 2 and then all the 3 hydrogen atoms. Likewise, the second carbon shares the electrons of 3 hydrogen atoms of the second carbon and then 1 electron of the first carbon. So, this is how we can represent the structure of ethane by using the electron dot structure, which shows that a pair of electron is making 1 single covalent bond. Okay. Next, we are going to learn the types of hydrocarbons. Hydrocarbons are generally categorized into 2 main types. One is saturated and the other one is unsaturated. What is meant by saturated? Already I told you about the single bond, double bond and triple bond. If the compound contains single covalent bond, then they are called as saturated hydrocarbons. Okay. If the compound contains, if you look at this structure, you could see that carbon, 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 these 4 are carbon atoms. Now, these 4 carbon atoms are bonded with a single pair of electrons, 1 pair of electron, and the other atoms are hydrogen. Okay. So, this is how carbon will get bonded with the carbon atoms, other carbon atoms with a single covalent bond are called as saturated hydrocarbons. If the carbon atom is bonded with the other carbon atom using 2 electrons, that means if 2 bonds are present between carbon and carbon atoms, then it is called as unsaturated. There may be double bond or triple bond in some cases of the carbon compound. So, if carbon containing double bond, they are called as alkenes. If carbon contains triple bond, then they are called as alkynes. Then how to name the compounds containing single bond? Carbon, single bond, carbon means they are called as alkanes in general. Okay. So, we can say saturated hydrocarbons can be generally called as alkanes, and unsaturated hydrocarbons are of 2 types. One is alkene and the other type is alkynes. Okay. Now, the other division is also there, aromatic hydrocarbon, but we are not going to concentrate on that. Just we are going to concentrate on these 2 categories only, saturated and unsaturated. As I said, saturated hydrocarbons are generally called as alkanes, which have the general formula CnH2n plus 2. Whereas unsaturated hydrocarbons are of 2 types, alkenes and alkynes. Alkenes have the formula CnH2n, which shows that compared to alkanes, 2 number of hydrogen will be lesser than the previous one. Okay. And alkynes have the general formula CnH2n minus 2, which means if you take the number of hydrogen, it will be getting reduced by 2 units from alkanes to alkynes. Okay. So, saturated and unsaturated hydrocarbons, if you take, they are the compounds containing carbon and hydrogen atoms, but saturated case it will be having single covalent bond between carbon atoms. If there are 2 carbons or 3 carbon atoms, whatever it is, so there will be one single covalent bond will be present in case of alkenes. Okay. Example, methane already we have checked. So, what are called alkanes? They have single covalent bond between carbon atoms and their names end with ANE. Okay, so in detail we are going to check how to name the compounds after this discussion. Okay, so methane, for example, meth meant for one carbon atom, and ANE for it is belonging to alkane, that is it contains single covalent bond. Okay, so that the name can be written as methane. Meth for one carbon atom, and then the second member is ethane. Eth for 2 carbon atom, N for single covalent bond. Okay, if you check the structure of this ethane, it shows that it contains one single bond between carbon and carbon, which means that one electron of the first carbon and one electron of the second carbon are mutually shared to form one single bond. Okay. Next, unsaturated hydrocarbons. As I said, unsaturated hydrocarbons are of 2 types generally, alkenes, alkynes. If it is alkene, then the carbon compound will have double bond between carbon and carbon atoms. See, can you notice this? There is a double bond between the carbon and carbon atom, which means that 2 electrons of carbon is shared with the other carbon atom, so that double covalent bond will be produced. And the examples are ethene, which is the first member of alkene. Because methane cannot produce alkene, it contains only one carbon atom. So, alkenes will not be possible in case of methane. Okay. Next member is propene. If you see that, prop for 3 carbon atom, ene for double covalent bond. So, the structure shows that it contains 3 carbon atoms, okay, and 1 carbon contains 3 hydrogen atoms. If you check this carbon, there is only 1 hydrogen. So, the valency of carbon is not satisfied, only 3 valency is satisfied. So, we have to draw one more bond to represent it is an alkene, so that 2 bonds are present in between the carbon atoms. And alkynes, they have the triple covalent bonds in between the carbon atoms, okay, in any place it may be. The first member of alkyne is ethane, where 2 carbon atoms are present. Between the 2 carbon atoms, there is a triple bond, which shows that 3 pairs of electrons, these are the electrons of first carbon and these are the electrons of second carbon. So, these 3 pairs of electrons are mutually shared to form triple covalent bond. Okay, and the next member is propyne, prop for 3 carbon derivative, ine for triple covalent bond between carbon and carbon atom. So, if you check the structure, it contains 3 carbon atom, but among the 2 carbon atoms there is a triple bond and the last carbon containing 3 hydrogen atoms. Okay. Now, what is mean by saturated hydrocarbons? Actually, generally hydrocarbons are called as organic compounds, I said, isn't it, that contains carbon and hydrogen as the elements. So, hydrocarbons contain hydrogen and carbon. Okay, in saturated hydrocarbons, all the bonds, that means it may be the bond between carbon and carbon atom, or it may be the bond between carbon and hydrogen atom. Whatever the bond is, it will be a single covalent bond type. Okay, and alkane is another name for the saturated hydrocarbon. So generally saturated hydrocarbons are named as alkanes, whose general formula is what? CnH2n plus 2, which means that n meant for the integers 1, 2, 3. Okay, if n is taken as 1, then calculate the member C1H 2 into 1 plus 2. So CH4. So we got the first member. So using that general formula, we can develop the next series of the family. Okay, the next homologue can be identified using this general formula. Okay. So these are some of the examples of saturated hydrocarbons. The first member is methane. The first member is methane. Okay. So where the formula is CH4, which shows that this compound contains one carbon and there are single bonds present between carbon and hydrogen. And the second member is ethane. Already I told you, meth for 1 carbon, eth for 2 carbon, prop for 3 carbon, but for 4 carbon, pent for 5 carbon and hex for 6 carbon. If more than 6 carbon comes, how to name that? If there are 7 carbon atoms in a compound, then they are called as heptane. If 8 carbon atoms are present, then the compound is named as octane. 9 carbon are present, then it is called as nonane. If 10 carbon atoms are there in a compound, then it can be named as decane. Decane. Okay, so this is how we can name the hydrocarbons, depends on the number of carbon atoms and also the nature of bond present. And these compounds are containing single covalent bond between carbon and carbon as well as carbon and hydrogen. So they will come under saturated hydrocarbons and specifically they can be called as alkanes. Okay, and depends on the number of carbon atoms, we can name them as meth, eth, methane, ethane, propane, butane, pentane, hexane, like that. Next, unsaturated hydrocarbons. Unsaturated hydrocarbons are the compounds containing either double bond or triple bond in the compound. And there are 3 types of unsaturated hydrocarbons. Actually, they aliphatic and aromatic, will call them as. What are the 3 types if you take? Alkenes, which contains double bond between carbon and carbon atom. Alkynes, which contains triple bond between carbon and carbon atom. And the next one is aromatic hydrocarbons. Aroma means sweet smelling substances, pleasant smelling substances. Okay, and they will be present as a structure, ring structure. So if there are more than 6 or 6 carbon atoms, then the 6 carbon atoms are arranged as a ring like this. They are called as aromatic hydrocarbons, and you will learn about the aromatic hydrocarbons in detail when you come to the higher class. Okay. Now in alkanes, alkenes and alkynes, there are different structural representations. Okay, what are the different structural representations if you ask? The first representation is straight chain, which means that any number of carbon atoms can combine, that means mutually share their electrons to form a long chain, linear chain. Okay, straight line, right? For example, if you take cellulose in plants, right, it contains many number of 100 number of carbons in a linear chain. Okay, if you take the first member, it is methane, which contains only 1 carbon atom. But if you take cellulose, there are n number of carbon linked by single covalent bond. Okay, so that It forms a linear chain compound called cellulose. Next, branched chain. What is called a branched chain? There will be some change in the carbon skeleton. We can call it as a skeleton. Carbon skeleton in the sense what? Straight chain means it will have a linear skeleton. Okay. Whereas if it is a branched skeleton, then the linear chain will get break up and form as a substituent. Okay. Which means if the carbon compound contains 4 carbon atoms, now in case of branch, a branch will be formed like a tree. You could have seen branches in the tree like that. The carbon, one of the carbon unit will add as a substituent, so that we'll get a branch like this. 3 carbon in a linear chain and 1 carbon will come as a branch. Okay. So in this way the branched chain compounds can be formed. Okay. And some of the common examples, if you take, pentane will be forming isopentane and neopentane. Okay. And generally they are called as isomers also. So let us check the other divisions of hydrocarbons in next class, children. And thank you for watching. To get new videos, subscribe our channel. Click on to the subscribe button so that you will be getting the latest updates. Thank you.